Hey you guys, this is Karen Smith. We're going to look at absolute value equations and maybe and then some. We'll do quite a bit of practice and hopefully you'll leave this video a little better understanding and feeling like more of a pro at solving these things. So get your pen and paper, let's get started. Okay, so here's a typical equation, right? We have an expression set equal to an expression, right? Okay, this is something we know how to do. We know how to solve for x, get x by itself. But what if we interject a pair of absolute value symbols on the left side here? So here we have absolute value of ax plus b is equal to some number c. And I'm also going to say that I need c to be a positive number, right? Bigger than 0. And it can also equal 0. That's fine. But the scenarios I'm going to talk about right now are basically when it's a non-zero positive number. Okay? To solve absolute value equations, you're going to need to learn the setup, as I call it. So you'll hear me refer to this, the setup, and that's what I'm talking about, what I teach you next. So keep that in mind. So here's the setup. You want to concern yourself with what's inside this absolute value symbol. Remember, a number's absolute value is its distance from 0 on the number line, right? So remember, a distance must be a positive measurement. So again, I'll say distance is always positive. So if you take 3 steps forward from where you stand, you've traveled 3 steps. If you take 3 steps walking backwards, you're still covering a distance of 3 steps. See, so a measurement like that, a length, has to always be a positive number. So distance from 0 is also a positive number. You can see here, if I take the absolute value of negative 3, or if I take the absolute value of positive 3, I'm still going to have an absolute value equal to positive 3. Now, here we go. This brings us to the setup. Okay. Since I know that what's inside here can be the negative version or the positive version of this number, we want to go back to the setup. And that is why we are only going to concern ourselves with what's inside here. This can be this value that's in there, the ax plus b, or it can be the opposite of that, right? Well, guess what? This is equal to that. So we can use that knowledge, since it's the positive version of that, and we can set this up. So let me show you how we're going to do it. We're not going to change any sign of the ax plus b. We're going to change the sign of the c, since we know it's equal to ax plus b. Watch how we do this. We'll write ax plus b can equal c without the absolute value symbols on this one, okay? And ax plus b, same thing, write the same thing here and here, can also equal the opposite of c. That's what is possibly inside the absolute value symbols, positive c or negative c, right? Because that is what could have a distance of c from this 0. So this is the setup, you guys. Then we can solve these 2 equations, okay? These are 2 simpler equations without the absolute value bars in our way. Let's look at an example with some numbers. Take, for example, the absolute value of x plus 5 is equal to 4. Okay, we want to take what's inside that absolute value symbol, right? The x plus 5. And we're going to write that out here. X plus 5 can equal something, okay? And x plus 5, just as is, right, can equal something else. So on the other side, we're going to write the negative 4 and the positive 4. So one of them is the same as what's there, right? Positive 4. And the other one's going to be the opposite of what's there, negative 4. Okie doke. So we've covered both directions there. Okay, now we'll solve. We can subtract 5 from both sides and solve them one at a time so you don't get confused and get frustrated with what you're doing. So here on the first equation, x is equal to negative 1. And we'll subtract 5 from both sides in the second equation. Cancels here, and it's negative 9 on the other side. So here are my two solutions. Now, when you go to check these solutions, check them individually. So when you're checking negative 1 as a solution, you'll plug negative 1 plus 5 equal to 4. You know, see absolute value of negative 1 plus 5, right? That's the absolute value of 4, and that is 4. Check negative 9 by itself, right? Negative 9, plug it into the x, is what? Negative 4. So the absolute value of negative 4 is 4, and it checks out. Yay! So let's check out another problem. Here in this example, we have the absolute value of x minus 3 is equal to 10. Now, what I'm about to tell you is absolutely crucial to you setting up these problems correctly. Always isolate the absolute value part of the problem before the setup. You want that absolute value, set of absolute value symbols to be by itself on one side of the equal sign. And the rest on the other side becomes the number on the other side. So you'll spend, if you have a bunch of stuff that's outside of absolute value symbols, you'll spend a step or two getting that stuff off of the absolute value symbols or away from the outside and onto the other side of the equal sign. In this one, we just have a minus 3 to worry about. So we need to make sure this guy is not there, right? That would be a problem if we went to set this up now. Without doing that, it would mess our problem up. So before the setup, let's take one step and we'll add 3 to both sides. Okay, so it'll cancel on the left side. Great. And then it pops up on the right as 13, right? So 13 on the right. And now on the left, we only have absolute value of x. And now the absolute value of whatever is by itself, and we can set this thing up. So we'll take just what's inside here and split it up as x can equal a negative 13 and x can equal positive 13. And look, it doesn't matter if you write the negative or the opposite one first or the positive one first. Just so you do one of these guys with a negative, and the other one is going to be the positive version. Okay, let's have 1 or 2 more examples and we'll be on our way. Okay, here we have the absolute value of x minus 10 divided by negative 2 equal to negative 6. Now, absolute value has to be positive, so we have that negative 6 here. But I'm going to tell you guys, be careful. Make sure you have that absolute value part isolated before you make a judgment call and snap to a no solution scenario. Don't do it right away. Make sure you have the absolute value isolated by itself on one side of that equal sign, then you can make that call. So let's see what happens when we multiply by this negative 2 that's divided here. So here, in order to get the absolute value by itself, we're going to multiply by negative 2 on both sides. So what does happen? We have negative 2 dividing off a negative 2. Okay, so now we have the absolute value of x minus 10 equal to negative 2 times negative 6. Remember, when you multiply two negative values, you're going to get a positive value, right? So these guys, we don't have to worry about that. We have a positive 12. And now we can enter the setup quite easily. So to set it up, we do this, x minus 10. So however it's written inside of that absolute value, leave it that way for the positive version on the right side and for the negative. So we'll have x minus 10 equal to negative 12. That's the thing that goes to positive negative, is the number side, not the absolute value side. Now we can solve these by adding 10 to both sides, right? So we'll add 10 and we'll end up with x is equal to 22 and x is equal to what? If you add 10 here, we're going to get negative 2. Okie doke. So 22 and negative 2, I'm going to let you guys check this one. All right. Now let's do one more for good measure and we'll be out of here. Actually, we'll have one more quick one after this. But here we have absolute value of 1/2 x minus 1. So that's the inside of my absolute values. Plus 1 is equal to 1. Fairly simple enough, but let's go ahead and isolate that absolute value part. Okay, so what do we do? We're going to add 1 or subtract. We're going to subtract 1 from both sides. Just isolate the absolute value symbol. So we'll bring down this absolute value symbol. We have an absolute value of 1/2 x minus 1. These guys cancel. And what happens there on the right? I have 1 minus 1, which is going to become 0 as well. Okay, so when I have absolute value equals 0, what happens? Now 0 is neither negative nor positive, but we do know that the absolute value of 0 is equal to 0, so it is possible to have that as an outcome. So we only have one thing we need to write. You just need to write 1/2 x minus 1 equal to 0 and solve that one thing. Okay, you don't have to write a negative and a positive version because 0 is just 0. So now we're going to add 1. We'll solve this just like any other equation. Okay, and let's see what we get. Then we will do what to rid us of the 1/2? We'll multiply both sides by a 2. So we'll take the 2 times both sides, right? So we'll cancel that. And x is equal to 1 times 2, or what? 2. So we have a single solution for this one. You can check it by plugging in a 2. 1/2 of 2 is 1. So now 1 minus 1, absolute value 0, and 1 is equal to 1. So it checks out. Okay. Now here's that last example that my trusty assistant reminded me that I should show you all, just for good measure to remind you that this could happen. Okay, so this example will be negative 3, absolute value of x plus 8 is equal to 5. So far it looks good because I have absolute values and I have a positive 5 over there. And so, but we have this negative 3 outside of the absolute value symbols. That is kind of putting a wrench in the works. So this guy, we got to clean that up before we set it up. Now remember, anything that's written as an integer without a fraction bar is what I'm talking about, can be pictured with a fraction bar by writing it over 1, right? Remember that. So remember there is that fraction bar there that's understood. So you can use that knowledge if it helps you feel more confident when you're creating your own fraction like this. But we're not going to do that. We're going to actually say, okay, if it's multiplied by negative 3, I'm going to divide by negative 3 on both sides. Just wanted to kind of remind you that it helps you sometimes people to be more confident when they're trying to get this part done. So divide by negative 3. On the left side, it cancels out, and on the right side, I have negative 5/3. Now let's rewrite this and take a look. X plus 8 is inside the absolute value equal to a negative 5/3. Whatever it came out to a negative number. And now that it is isolated, that's a problem. Absolute value is not going to be a negative. That's what's wrong right here. Because I have a negative value opposite of the absolute value sign, this is going to cause me to have no solution. So that negative value, once you have absolute value part isolated, if you have a negative value on the other side, this is bad, right? This is going to stop you. So no solution for these. You can only do this and make this decision once the absolute value part is isolated. Okay? So be careful with that. Don't just jump to that conclusion unless you've isolated absolute value symbols. Okie dokie, you guys. This has been a presentation on absolute value equations. I hope it helps, and I'll talk to you guys soon.